I'm MJ, and I'll be talking about CLI tools in Python. Uh, so I want to start this talk with a story way back in 2023. So back then, the market was really bad. It was terrible. I was trying to break into the industry, right? But I just couldn't. And it's not because, you know, it's not because of me personally, I think. I think it was just the market was just that bad. So I needed to kind of distract myself, right, from this terrible market. So that's why I started kind of looking for dev groups online. Uh, and most of my motivation came from I just needed something else that can help me forget that the market was just bad. And so I found this dev group. It's a dev group in the UK. Sorry, the mic. It's a dev group in the UK. And we kind of decided to collaborate on GitHub. We used GitHub to collaborate, and we started working on projects together. So the thing about GitHub is that it's a Git hosting platform, and there's this concept called issues and pull requests. Okay, so issues you can think of it as like problems, and then pull requests you can think of it as proposed solutions to these problems. And in GitHub, there's this feature called labels where you can kind of without clicking on a specific issue, you can kind of add labels to it so that on a quick glance, right, I can quickly tell what this thing is about. Like, for example, I know that it affects the infra, I know that it's high priority, and I know that it's a feature request, right? So you could imagine if you have a lot of like issues and pull requests, how helpful labels are, right? But the problem was to create a label in GitHub, it's a 5-step process. First, you click this label button, you add the name of the label, description, the color, and then you click this create label button. And there's no way to kind of automate this. This is like this is just for one label, by the way. Imagine if you have like 20 labels. That's like 100 steps. And you know what? That's not even the worst part of it. The worst part is like if you create a new project in GitHub, all the labels you've configured from your previous project, they're gone. So you have to do this entire process all over again. And I thought this was stupid. Okay? I thought it was stupid. So I created a tool called GH Label. And instead of like 100 steps, why not just one step, right? So GH Label is a CLI tool. So but how do we create CLI tools in Python in the first place? So the obvious answer, if you're a beginner and you're learning Python, the first thing you will learn is argparse. So argparse is a part of the standard library, and it's really good for like quick and dirty scripts. So if you write like a CLI tool and then you write it once, you don't really intend to maintain it, argparse is like one of the best libraries to use. But you know, some tools they get big, okay? Like think of Docker, for example. I mean, Docker is not written in Python, but it's a it's a big and hefty tool, right? And devs have to maintain that. So in Python, back then the standard was to use click. This was the standard back then. Like it has more features. It allows you to it allows you to maintain like CLI tools easier compared to argparse. But that was back then. Right now, the modern way of doing it is via typer. So typer is built on top of click. So anything that click can do, typer can do. Uh, but what is typer? So typer is the fast API of CLIs. Why is it the fast API of CLIs? Because the creator of typer and the creator of fast APIs is the same guy. It's Triangulo. So if you know fast API, you know typer. I'm not joking. Like the syntax is very similar. So and it's really easy actually to write a CLI tools using typer, and I'm going to show you examples of it later. So for example, I have this command, right? Let's say a user writes this command: ghlabel setup -p. So ghlabel is the name of the tool. Setup is the command. So how do we write a command in typer? It's just this. So you install typer, you import typer, you initialize it, you create a function that contains the logic for it, right? And then you add a decorator and you name the command as whatever name you want. In this case, it's setup. So if the user types in ghlabel space setup, whatever is below this will run. Okay. So, but how about options like flags options, right? What if we want more? Uh, how do I say it? What if we want to give the user more freedom, right? So this is a flag or an option, this minus p thing, and the way you write it in Typer is this. You just add it as an argument. So the important bit here is the type of the argument. In this case, it's a boolean. I'm sorry, the laser thing is not working, so I have to point it. It's a boolean. So if this thing exists, right? If the user writes minus p, we can just check if it's true. Then the logic will run here. Else, it's something else, right? And as we can see, what is the help text for minus p? It's dry run on preview. So if we're how do I say it? Like it runs JH label setup, but it doesn't do anything. It just shows you the preview of it. So it's like a good way to check if the output is actually correct. And if you want to learn more about Typer, this is the docs for it. It's actually one of the easier libraries to learn. I think you can I think you can learn it in less than a day, and I'm not even joking. That's how simple it is. So that was 2023, right? Uh, After this, like around like October, I got a job. Finally, I got my first like job. Is the current company I'm still in. uh, it was a really bad market. It took me 6 months to get this job, and then a couple months after that, right, 2024, I was given this. I mean, the company kind of trusted me enough to give me this crazy project. I think it's like a crazy idea because the problem was we have this like legacy web application, right? Legacy web application. So think of like something that like spaghetti code base that existed for a very long time, and the problem was we have this mobile app that it doesn't have all the features of this legacy web app, right? I mean, it has some features, but not all. But eventually, we want to port everything there. We want to port all the features in the mobile app. But the issue is that this legacy web app, it changes fast. It changes fast. Like there's a lot of new features, a lot of bug fixes. If we develop the mobile app, we would have to maintain two apps at the same time. So this was like, no, we didn't want this, right? So the idea was like, what if there's this legacy web app and something in between, right? That kind of like if we update the web app, we just run this thing, and then it spits out a mobile app. Okay, so that was the idea behind this. So I was tasked to build a POC, which is a proof of concept. It's not actually for production use, but it's more like to prove that this thing is possible in the first place. So to solve this kind of problem, right? We need to know transpilers. So transpilers is just source code. There's something in between, and then it spits out the source code. So, for example, in this legacy web app, right, we have this like full stack app. The back end and the front end, it's intertwined. So we want to kind of separate it. So like the full stack becomes an API, and then Jinja becomes HTML, CSS, JavaScript. That was kind of like that was kind of like the high level overview for this. Okay, so for example, we have this sample endpoint, right? We want to kind of create a new endpoint for it for the mobile app, so an API endpoint, and then for the return render template, this is specific to Flask. We don't want to return an HTML. This will spit out an HTML, like Jinja, and then it will spit out an HTML string. But we don't want that because we want an API, so we want to spit out a JSON or a dictionary, right? So this was kind of like the idea for the backend. So my instinct, again, because I was, a new guy, my instinct was to use regex. So for example, because the idea was like, if we can find this thing, right? We can find return render template, then we can do some transformation, and then, yeah, that was the idea. But the problem was finding return render template in the code base in the first place. So think of this pattern, for example. So this is the important bit. Let's say, for example, match everything from here to here, right? This thing, and then match everything this that is not a closing parenthesis. So that was the idea, like match everything. But this is faulty. Back then I did not know, but this is faulty because value can be anything, any Python object. Think it can be a tuple, for example. So if it's a tuple, it's a closing, opening, closing parenthesis, and then it will match only up to here, and then the code will just break. So yeah, so I raised, how do I say it? This is like a limitation of regex. Regex does not understand nested groupings. So I raised this to my senior. Again, I was a junior dev, so I raised this to my senior. I told him, hey, I have this problem. What can we do about it, right? Can you help me solve this problem? He told me about ASTs. Like, why not read up about it? And this is my first exposure to AST. So AST is an abstract syntax tree, a tree representation of the code. I know it doesn't really make sense for a lot of you, but it's kind of like this. Let's say, for example, you have this example return render template, right? We want to see the tree structure of it, so we just use the standard library, AST. It's part of the standard library. You don't need to install anything. We parse it, convert it to AST, and then we just dump it for now because we just want to inspect it. We're not doing anything. So it will look like this. It doesn't really make sense, right? But don't worry. How about let's see the tree, like convert this to a tree. Oh, now it makes a bit more sense. So let's say we have a return node, then we have value. I'm not sure if you can see at the back, but there's value and then type call. If we go back, we have the return node, value, type call. Go back. Under call, there's a func with type name. We go back. Under value, I mean under call, there's func type name. And then under name, there's ID of render template. Under name, ID render template. Okay? So this is the tree structure of the Python code, right? So you know a crazy idea. What if we just swap this with something else? This call node here. What if we just replace it with something else, right? So, but the problem is, how do we even get to here in the first place, right? How do we even find this thing in the first place? So there's this thing called visitor pattern. Don't worry about it. But in Python, in Python AST, the way you implement the visitor pattern is via using the node visitor. But you can think of it as like node visitor allows you to visit all nodes. But we don't want to visit all nodes. We only want to visit the return node, right? But we don't want to visit return nodes. We don't want to visit all return nodes. We only want to visit the return node that is render template. Okay, let's go back here, right, from the tree. The type of node that value is call, right? So we start from here. This is the node, the return node, and remember visit underscore return. The type of value node that value is call. Back, the type of node that value that func is name. The type of node that value that func is name. Go back. The value of node that value that func that ID is render template. Go back. Node that value that func that ID is render template. This is how you visit, so that we can visit the specific kind of statement return render template, right? And then once we find it, we just mark it as found. And then if it's not found, just ignore. Okay, so that was using the node visitor. So how about transforming the node, right? So AST allows us to transform the node via the node transformer. So it allows you to kind of transform all the nodes. But we don't want to transform all the nodes. We only want to transform the return nodes, but we don't want to transform all the return node. We only want to transform the specific return render node, right? So we use the previous class to find the return render template. If it's not found, ignore. If it's found, continue. And this is where the magic happens. This part here is where the magic happens. As you can see, it creates a new node, a dictionary node, and then it just puts it under the value of the return node. and that's it. And then putting it all together, right? The concepts. So we have the source code, right? We start from here, return render template. We convert it to AST. We visit and transform the AST, and then we convert it back to source code, and then you do something here. So in summary, again, we have the source code. We convert it to AST. We visit the specific node, and then we transform that specific node, and then we parse it back to source code. So that was the backend. Cool. That was fun, right? But that was the easy part. Dun, 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 dun. Insert boss music. So the if you want to learn more about AST, uh, how do I say it? There's a docs for it. It's part of the standard library, as you can see. Uh, but again, for transforming, how do I say it? Transforming code bases, right? For transpiling, typically we don't use AST, not because it's, how do I say it? Not because it doesn't work, but mostly because AST doesn't contain formatting. It's only really the essential information, right? But let's say, for example, you have like input and then you have an output, right? And then you check the diff. If you use AST, what you will see is a lot of red lines because the white space changed. And you do not want that, because if you have like a large code base, for example, hundreds of thousands of lines of code or millions even, you could imagine how noisy the diff would be, and you wouldn't even know which, if the part that you change is it the actual changes that you want. But typically we use a library called libcst. This is from Instagram. It's open source. Meta. It's part of their internal tooling. So it's kind of like AST. It's a CST tree, so complete syntax tree. And the reason why we use this library for this specific problem is because the syntax for libcst is very similar to AST. So whatever you see before in the slides before, you just need to modify it a little bit, and then it will just work. And then once you check the diff, it's only the changes that matter, not the white spaces. Okay? So that was the back end. Again, that was the easy part. The hard part is the front end. And the reason why it's hard is because back then, 2024, we couldn't find like documentation for, how do I say it, Ginger AST. Maybe it exists. I don't know. I have no idea. But we couldn't find it. Like a good documentation for it. Like, how can we manipulate Ginger, right? So again, being the junior that I am, I went up to my senior dev. I told him about this blocker, right? I told him that, hey, this is an issue. Like, how do we solve it, right? And he was like, maybe we have no choice but to write our own parser. Okay, so why not check out uh, this thing called Ply? So that's what I did. So Lex and Yak written in Python. Again, it doesn't matter. It doesn't matter. How do I say it? What's important is the lexer and the parser. So what the hell is the lexer and the parser? So in the lexer, you define the tokens. In the parser, you define the grammar. Okay, MJ, I still don't know what this thing means. So imagine we have a phrase called imagine we have the phrase, the quick brown fox jumped over the lazy dog. This entire thing is the grammar. The individual words are the token. Meaning, a grammar is just the arrangement of tokens. So you can imagine we just need to kind of define the tokens, and then after that define the grammar. So looking back at the example, like the Ginger variable, for example, we have two opening brackets, a variable, and then the closing bracket. So we need to define the tokens for that, right? So in Ply, the way we do it is via this. So we just import again, don't worry about it, the from Ply import lex. So first define the tokens, expression, variable, and expression. We define the state. For now, it doesn't matter. And then we define the token here, t underscore expression. And then under it, what is what will the lexer look for, right? What will the tokenizer look for So if it finds this two opening brackets, for example, make how do I say it? Mark it as a expression token. But then there are cases where, for example, the pattern can be generic, right? For example, for the variable token, right? And this thing, it can match a lot of things, right? If you have like an input string, you could imagine it could match a lot of things, but we don't want it to match everything that has this pattern. We only want to match it when the state is of state expression. So when here we have the starting token, right? And then we kind of start a new state so that if the state is on state expression, that's the only time we can mark this pattern as a variable token. And then lastly, for the end expression, two closing brackets, and then we set the state back to initial. And then just ignore this for now, but this is running the lecture. And then for the parser, uh, we used the tokens from the lecture before so that we don't need to define it again. And then this is like the kind of like general syntax you do it. Uh, for this is like the grammar, and then after this colon are the rules for this grammar. Rules meaning you can define multiple rules, and the way you kind of distinguish between the rules is via this pipe operator. So, for example, in Jinja, there's this concept called filters, Jinja filters. Uh, let's ignore it for now, but I'm just showing you guys how to kind of have multiple tokens. I mean, have multiple rules for a specific grammar. So, and the way you distinguish between the rules, right, is you just check the length. So this is like index 0, index 1, 2, 3, 4, and then the length of this is 5. So if the length is 5, that means it has filter on it. Otherwise, we're using this rule, right? Ignore this for now. Ignore everything actually for now, except this. This is important. The index of 0, because whatever you write here, right, and then you store it at index 0, this will replace the part of the input stream, right? This will replace whatever match this rule. So if it finds this expression variable and expression, whatever is here, swap. Okay? And then this is how you use it. Generally, you run the lexer, you run the parser. Ignore this for now. This will all make sense once I show you the sample input and the sample output. So this is the sample input. We have an HTML string, HTML file, and then this is the output. Okay? As you can see, expression, variable, and expression, P of 0, index 0, swap. And then if we go back here, there's this thing that's appended after it. And since we're using like a, how do I say it? We're not using full stack Flask. We're using an API now, right? So we fetch from the endpoint, and then we're returning JSON now. So we kind of, the way you access, right, a JSON object is just the thing here, the data, and then the key, right? And that's the value. And this is like, this gives an illusion that we swap the Ginger variable to its value. So if you run the Flask back end and then you run the front end, and then you see the output, I mean, in the browser, you will see that the value of the Ginger variable. Okay? So that's about it. If you want to read more on Ply, here's the docs for it. If you guys are curious what we use to kind of package it to APK, Android, iOS APK, we used Cordova. But Cordova is not, how do I say it? It's not really written in Python. It's written in JavaScript. That's why I did not include this here. And I forgot to introduce myself, so I'll do it now. So I'm MJ. I'm a software engineer. I'm human, by the way. I'm not AI. I have 2 years of experience. I interned mostly at startups, and then I'm currently employed at H Utility, and we're hiring, by the way. We're looking for Python or C# devs. So if you wanna, work with us, do crazy stuff. Usually for the Python team, we maintain like the a legacy web app, the thing that I was talking about before. But the company has enough budget to allow the devs to explore crazy ideas. So yeah, we do it on the side. We explore those ideas. So just send your CV to H Utility, and then where to find me? I have no socials. I'm kind of a private person. I also have no LinkedIn, but you can find me at GitHub, SEYLU, and I sometimes live code on Twitch. Uh, and then this week I'll be exploring Quezon City. So if you guys are around the area, please say hi. I actually really appreciate it. And if you happen to maybe in the future travel to where I'm from Tacloban, just slide into my DMs. I'll show you guys around. And if you have any questions, just this is my business email. And any questions?
So if you have questions, please feel free to ask. Okay.
Good afternoon, sir. I just want to ask if you would suggest if we try other, let's say, tools. So what you mentioned was Ply, like Lex and Yak. Would you suggest other tools like, let's say, PyParsing or Lark?
Actually, how do I say it? I've tried Lark before, but the thing about our company, we have this kind of allergic reaction to new tools. We only really use tools that are, how do I say it, proven, tested and proven. Uh, Ply has been around, I'm not sure, maybe since the 90s. I have no idea, or maybe early 2000s. It's been around for a while, and it's proven that it works. So, yeah, that's why we use Ply.
Questions, please proceed to the front. Na lang.
Hello, good afternoon. So the business requirement was to separate the front end and the back end. So I just want to know if you could share the reasoning behind instead of writing it, you created a transpiler.
I've actually explained this early on during the problem set. The issue was that we did not want to maintain two apps at the same time. That was the issue. And we did not also, if there was like a separate front end, that would mean it would be three, right? We didn't want to do that because we're a small team and the company has been around for a while, but we kept the team small. And it was only recently that we're trying to expand. Mm. All right. Thank you. Thank you for your question.
Hello. So yeah, just a quick question. How do you plan to separate the since mobile app are more complex now, right? So how do you plan to handle the backend side, the calling from the APIs or the data storage, in case you convert it to the mobile app, the website? Example this website calls an API like authentication, or how do you yeah resolve that when it's converted to mobile, or not yet?
Thank you. Thank you for that. I built a POC, which is a proof of concept. It's not ready for production use. We did not release the code for it because again, it will just break. There's a lot of things that breaks, but we've managed to kind of solve most of Jinja. But there's like this really weird edge cases, so we're not yet on that stage. But thank you for the question.
Any more questions? We have 2 more minutes for questions. If you have any questions, please raise your hand so that I can bring the microphone to you. Okay, it seems like we don't have any more questions. Thank you so much, Sir MJ.